All right, guys, we are still doing literal equations, but now they're not one steps, they're multi-steps. So this is going to be a little bit longer, so just hang with me here. Basically, again, I'm trying to show you something you know and show you how it relates to the literal equation, okay? So this is a two-step equation, and believe it or not, we can simplify this literal equation using two steps as well. So here we're solving for x. Here we're solving for n. Notice the positioning here. It looks almost exactly alike. So you would tell me my first step is to subtract 3 on both sides. Well, here I'm going to subtract c on both sides. So here I bring down my 2x. I can turn this into a numerical number, 8. Here, I'm going to bring down my an equals, and I have to write this because I can't combine it, f minus c. Okay? Okay, next. Here, to get x by itself, I divide both sides by 2. Here, to get n by itself, I'm going to divide both sides by a. Okay, so here I get a numerical answer, and here I get an expression in terms of FC and A. Okay, and you have to know what you're doing here, because these are multiple choice tests, and they'll have these in reverse. They'll have C minus F. They'll have all these letters in different positions, so you really got to know your operations here. Okay, right, let's do another one. Okay, solving for x, first thing I would do, I would add 8 to both sides. Okay, so notice here, I'm solving for v. Notice the positioning. All of this is about the same, okay? So I moved this whole term by adding because it was negative. So I'm going to move this whole term by adding. So I'm going to add PA to both sides. Okay? Combine to get a 10. Bring everything else down. Okay? Here I'm going to write these. G plus PA equals 1/8 WV. Okay. So over here, the 5 is divided. So I'm going to multiply both sides by 5. And I'm left with 1x or x. And then when I multiply, I get 50. And for v, so I'm going to have to take 2 steps here. I'm going to multiply both sides by 8. And since there's 2 terms here, I'm going to have to use a parenthesis. See, there's 2 terms, so I have to use a parenthesis. Now I've got WV equals 8 times G plus PA. And to solve for V, I'm going to divide both sides by W. So there's my, didn't mean to do that. There's my expression. Okay? All right, let's do another one here. All right, solving for x. Now I want y'all to notice something. Y'all, the x is in the denominator. So we're going to have to fix that in a bit. Okay? I'm going to subtract 10 on both sides. Okay. Notice here we're solving for b, and b is in the denominator, so I'm going to have to fix that. But just like I took this whole term and subtracted, I'm going to take this whole term and subtract. I'm going to subtract h cubed. Okay. So I have f divided by b, and here I have p minus h cubed. Here I have 5 divided by x. 100 minus 10 is 90. Okay. Now, x is in the denominator. It cannot be in the denominator. So if it's in the denominator, the way to get it in the numerator is to multiply both sides by x. In other words, it's divided. I'm going to multiply. So now I have 5 equals 90x. Same thing here. I'm solving for b. It cannot be in the denominator, so I'm going to multiply. And again, I'm going to have to do that because it's two terms. I'm multiplying both sides by b. Okay, so now I have f equals b times p minus h cubed. Here, I'm going to divide both sides by 90 to get x by itself. Okay. Here, to get b by itself, I'm going to divide both sides by p minus h cubed. So I get b equals f divided by p minus h cubed. And over here, I could reduce this, I don't know, to get 1 over 18. Okay. All right. So I really couldn't find like a regular, equation. So I just figured I'd work one of these and then we'll work another one. Okay. So these are some special cases. So let's watch carefully. I'm supposed to solve for v here, and v is in two terms. So the way I get v to be written twice is to recognize that v is a greatest common factor. It is a common factor of the two terms. So I can pull the v out as a common factor. I can pull the v out as a common factor. And so if I divide by v, I'm left with a t plus n. You see I did that? I pulled v out as a common factor. Okay, now that the v is written one time and I'm solving for v and it is separated by multiplication, division is how I'm going to get rid of the t plus n. I'm just going to divide both sides by t plus n. So I get v equals c divided by t plus n. Okay? All right. Here, I'm solving for b. First thing we need to notice is that not only do I have two b's, they're on opposite sides of the equal sign. So what I'm going to do to help myself out is I'm going to move this entire term over to get my b's together. Well, this entire term is added, so I am going to subtract GB from both sides. So I get m equals dB minus GB. Okay? Just like over here, the b needs to be written one time so I can solve for it. So I'm going to pull the b out as a greatest common factor. And if I pull the b out, I'm left with d minus g in the parenthesis. Okay? So if I'm solving for b, I need to get rid of d minus g. I'm going to divide it. And there's my expression. Okay? All right. Got a couple more. Okay. All right. Solving for x, solving for n. Notice. Okay. So, y'all, you would tell me that my first step is to distribute here. So, y'all, my first step here is going to be to distribute. Notice the variable I'm solving for is locked up inside this parenthesis. So when I distribute here, it's b times a times n, b, a, n. Then b times 5c is going to be a positive 5bc because I'm multiplying. Okay. All right, now solving for n. Just like I'm solving for x, you would tell me to subtract 10 on both sides. Subtract this term. So here I'm going to subtract 5bc from both sides. Here, I would have BAN equals, and I've got D minus 5BC. Okay, solving for N. Okay, the 6 is multiplied over here, so you would tell me to divide both sides by 6. So here, these are multiplied by N, so I would divide by BA to get N by itself. All right. Okay, if you did the extra credit, you may remember this. Squares and square roots are inverses of each other. The way I get rid of something squared is I take the square root. The way I get rid of a square root is to square it. Okay, so we're going to do 2 of those. So here, with a regular equation, I need to get rid of this square root, so I'm going to do the inverse, and I'm going to square. And to be fair, I've got to do it to both sides. So I'm going to square both sides. So the square and the square root cancel, leaving me with 2x plus 7. Don't forget, I've got to square the other side, so I get 25. So here, I'm solving for j. I've got a square root. The way I get rid of it is I square it, but to be fair, I've got to do it to both sides. Okay? Square root and square cancel. I've got sj plus 4d. Here I have m squared. Okay, so here you would tell me to subtract 7 on both sides. So I got 2x equals 18. Okay, here, just like we subtracted 7, we're going to subtract 4d, because remember, I'm trying to get the j by itself. So I'm going to subtract 4d on both sides. So now I have sj equals m squared minus 4d. Solving for x, solving for j, I'm going to divide both sides by 2. So here I'm going to leave the j and divide both sides by s. So here's my expression. Okay. All right, last one. Notice this had a square root in it. This has a square in it. Okay. I'm going to show you a different way. This is a quadratic, so I'm going to show you a different way to solve a quadratic here. It's kind of cool. I'm solving for b, so notice my b's got a square on it. So first thing I would do is I would subtract 5 on both sides. Okay, so the first thing I'm going to do here is I'm going to add t cubed to both sides. Okay, so here I have x squared equals 54 minus 5, which is 49. Okay, over here I'm going to have 4n plus t cubed equals fb squared. Okay. Here the x is by itself with a square, but here I've got an f and it's multiplied, so I'm going to take an extra step over here and divide by f to get rid of the f. Okay, so now I've got my variable squared, 4n plus t cubed over f. Okay, to get the square off, we're going to do the inverse, and we're going to take the square root of both sides. So that's going to, the square and the square root cancel, and that's going to leave me with square root of 49, which is 7, and it's actually 2 roots. It's a positive and a negative 7, but that's okay. You'll learn a little bit more about that next year. Here, I need to get the square off, so I am going to take the square root of both sides. So this is my expression, and notice it has a square root symbol on it. All right, make sure you keep these notes because you've got a Delta Math tomorrow on this, okay? And you're going to need to look back at these. Okay, y'all have a good day.